In this video, we're going to briefly introduce higher order derivatives. In doing so, we are following the order of the textbook, although we will not apply this material until a later section. The idea behind this is easy enough. The derivative of a function is a function. So you can take its derivative. You know, if we have f of x equals x cubed, the derivative of this is a function. It uses function notation and everything. 3x squared. The 3 comes down. 3 minus 1 is 2. And this is a function, and we can take its derivative. The 3 remains there. The 2 comes down and is multiplied by 3. 2 minus 1 is 1. Our notation here is that because we're taking the derivative a second time, we put a second apostrophe up there, and we call this the second order derivative. If we wanted to take the derivative a third time, we can certainly take the derivative of 6x. Now we have 3 little apostrophes up there. And that's the third order derivative. We could keep doing this forever. At this point, we change up our notation. And instead of writing apostrophes, we just write in parentheses up here how many times we're taking the derivative. The derivative of 6 is 0. This is 4th order. I don't think I've ever run into a situation where we needed to keep taking derivatives after this point. I mean, I don't think I've ever seen an application of a 4th order derivative. But mathematics is a vast field, and I can hardly say that I've seen all or even most applications. So who knows? If we're using our Leibniz notation, remember, we can write the derivative like that. Then our notation for the second derivative, I don't like this notation as much as this notation. We put a 2 here for second, and a 2 here for second. And what I don't like is that it's easy to forget which of these numbers comes between the d and the variable, and which of them comes after the variable.